All right, in this lesson, we're still determining the inverse Laplace transform of a function. But for the functions that we're going to be using today, we're going to need to break them apart first using the method of partial fractions. And so let's start with the simplest example, which is when we have non-repeating linear factors in our denominator. So let's start by setting this equal to, so we've got 7s minus 1 over our s plus 1 times s plus 2 times s minus 3. We're going to set that equal to some constant divided by our first factor, s plus 1, plus some other constant b divided by our second factor, s plus 2, plus a third constant c divided by our third factor, s minus 3. All right, next thing we're going to do is multiply both sides of this equation by this common denominator here. And when we do that, all of this will go away. We're just going to be left with 7s minus 1 on the left side of the equation. And then we're going to get a times these two factors, s plus 2 times s minus 3, plus b times these two factors, s plus 1 times s minus 3, plus c times these two factors, s plus 1 times s plus 2. Now, the simplest way then to solve for a, b, and c in this type of problem where you've got non-repeating linear factors is we're going to come up with some values for s that we can plug in that's going to simplify this equation. And you can see that the first value we're going to plug in is going to come from here. It's just negative 1. We're going to make these three factors one factor at a time equal to 0, and then that will get rid of a lot of this. So let's start by plugging in negative 1 for s. And notice what happens here. So 7 times negative 1 is negative 7, minus 1 is negative 8. Negative 1 plus 2 is 1, times negative 1 minus 3 is negative 4, so we get negative 4a. And then negative 1 here, this is going to make this whole thing 0, and it's going to make this whole thing 0. So we're done, and we can see that a is going to be equal to 2. Now let's do that for the next one. S equals negative 2. Negative 2 times 7 is negative 14, minus 1 is negative 15. This one's going to be 0. This will be 0. Over here we get negative 2 plus 1 is negative 1. Negative 2 minus 3 is negative 5, so this is going to be positive 5b. So b is going to be equal to negative 3. And then let's plug in 3. 3 times 7 is 21 minus 1 is 20, is equal to, well, these two will both go to 0, and this one is going to be 3 plus 1 is 4, 3 plus 2 is 5, so that's 20c. And so c is equal to 1. Now we can plug in these three constants for our a, b, and c here. And so this is going to be 2, negative 3, and 1. And now we've really simplified this problem, because now the inverse Laplace transform of all of this is going to be equal to the inverse Laplace transform of, well, let's bring that 2 out front. So 2 times the inverse Laplace transform of 1 over s plus 1 minus 3 times the inverse Laplace transform of 1 over s plus 2 plus the inverse Laplace transform of 1 over s minus 3. And now all of these are in this form up here. So all of these are going to be e to the at with different values for a. So here we can see that the value for a here is negative 1. So this is going to be 2 e to the negative t. Here the value for a is -2, so this is going to be -3 times e to the -2t. And over here, the value for a is 3, so this is going to be e to the 3t. And there is our inverse Laplace transform for this function of s. All right, example number 2 is very similar to example number 1 in that it has linear factors in the denominator. The difference is that one of those factors is repeated. So there's a couple of things that we need to do differently for this one. But we're going to start off the same way. We're going to set this function s squared plus 9s plus 2 over s minus 1 squared times s plus 3. Set that equal to some constant a over s minus 1 plus some constant b over s minus 1 again, plus some constant c over s plus 3. Now, here's where the difference comes in. When you've got a repeated factor there, for this one, we're going to square it. So if this were cubed, we'd have s minus 1 plus s minus 1 squared plus s minus 1 cubed. All right, so now we proceed as we did before. We're going to start by multiplying both sides by this common denominator here. So we get s squared plus 9s plus 2 is equal to a times s minus 1 times s plus 3 plus b times just s plus 3 plus c times s minus 1 squared. All right, now we're going to choose some values for s that are going to simplify this. Let's start with 1. If we plug in 1 here, we get 1 squared is 1, plus 9 is 10, plus 2 is 12. And if we plug in 1, this term is going to become 0, so will this term, and we're going to be left with b times 1 plus 3. So that's going to be 4b. And if 4b equals 12, then b is equal to 3. All right, next let's plug in -3. So -3 squared is 9, minus 27 is -18, plus 2 is -16. And that's going to be equal to, well, this term and this term will go away, and we're going to be left with -3 minus 1 is -4, squared is 16, so this is 16c. And so c is -1. All right, now there's no values that we can plug in that are going to make this term and this term go away, but still leave us with an a. So what we're going to do is just plug in some other value for a, knowing that we already know b and c, so we can figure this out from there. Let's go ahead and just plug in 0. That'll just give us 2 on this side of the equation. And that's going to be -1 times 3 is -3a. Over here, this is going to be plus 3b. And then -1 squared is +1, so plus c. And we know that b is 3, so we're going to replace this 3b with 9. And we know that c is -1, so that we'll replace that plus c with -1. And now we can solve for a. If this is going to be 8, if we subtract 8 from both sides, we get -6 is equal to -3a. So a is 2. So let's put a equals 2 over here. And then we can replace these this a, b, and c with 2 and 3 and -1. All right, now we can find the Laplace transform of this. this is equal to 2 times the inverse Laplace transform of 1 over s minus 1 plus 3 times the inverse Laplace transform of 1 over s minus 1 squared minus the inverse Laplace transform of 1 over s plus 3. All right. Now, these two are just like this. It's just going to be e to, in this case, 1t. So this is going to be 2 times e to the t. This one's going to be negative, let's give ourselves a little more room, negative e to the negative 3t. And then this term in here, notice that we've got this squared here. If this were just s, this would be 1 over s squared. So 1 over s squared, we could write that as 1 factorial over s to the 1 plus 1, right? And we can see that that is just t to the n, where n is 1. So this is just t, or it would be if this were 1 over s squared, but we replace that s with s minus 1. So remember, that's that translation where we're going to multiply by e to the at. So this is going to be plus 3 times t times e to the 1t. And so there's our Laplace transform for that function of s. All right, this last example is a bit more difficult because we have this quadratic factor here in our denominator. And we want to first check that this has to be a quadratic factor, that we can't reduce it to some linear factors. If we were to plug this into the quadratic formula, we could see that the discriminant would be b squared, which would be 4, minus 4 times a times c, which would be 20. So this is going to be a negative discriminant. So we're stuck with that quadratic in our denominator. So we have to do things a little bit differently. We're going to start off, as before, by taking this whole function, 2s squared plus 10s over s squared minus 2s plus 5 times s plus 1. And we're going to set that equal to, now what we're going to do is with this quadratic factor here, we're going to complete the square on that. So s squared minus 2s, we need to plus 1 there, and then that would leave us 4. And so if we completed the square, that's going to, if factored this is going to be s minus 1 squared plus 4, which is 2 squared. And we saw in examples from the last lesson that we really like this this format because it looks a lot like these down here. Okay, so so this is going to be our denominator here, s minus 1 squared plus 2 squared. And then what we're going to put on the top is a, that's the first constant that we're going to be trying to figure out, times this here, this s minus 1, not squared, just s minus 1. And then plus this base here, this beta in our formula, times b, so 2 times b. And then the c is the same as before, so just c over our linear factor here, s plus 1. All right, now, as before, we're going to multiply both sides of this equation by our common denominator, and we're going to be left with 2s squared plus 10s is equal to, here we're going to have s plus 1 times all of this. So we're going to have a times s minus 1 plus 2b times s plus 1 plus c times all of this. So c times s squared minus 2s plus 5. We could also put it in this form, but it really doesn't matter here. Okay, so the next thing we want to do is start plugging in some values for s that are going to make this simpler. So let's start with -1. That's going to make this whole term go away. So if we plugged in -1 here, -1 squared is 1 times 2 is 2, minus 10 is -8. And this whole thing will go away, and we're going to be left with, let's see, -1 squared is 1, plus 2 is 3, plus 5 is 8, so 8c. So we get that c is -1. All right, now let's plug in 1. That'll make this a go away. So if we plugged in 1 here, 1 squared is 1 times 2 is 2, plus 10 is 12. And then this becomes 0, and we get 1 plus 1 is 2 times 2b is 4b, plus 1 squared is 1, minus 2 is -1, plus 5 is 4, so we're going to get 4c. But we know that c is -1, so this is going to become -4. And then if we add 4 to both sides, we get 16 over here. Divide by 4, we're going to get that b is equal to 4. All right, so we've got 2 of them now. Now there's nothing else that we can just make some things disappear with. So let's plug in 0 now for s. So if we plug in 0, this becomes 0 on the left side. This is negative. This is just going to be 1 out here, so this is just going to be -a plus 2b, and then plus 5c. And we know that b is 4, so this is going to be 8. And c is -1, so this is -5. So that's 3. We move this a to the other side, we get a is equal to 3. So a equal to 3. All right, now we can plug those in up here, and we're ready to start doing our inverse Laplace transform. So this is 3, b is 4, and c is -1. All right. So now we have 3 times the inverse Laplace transform of s minus 1 over s minus 1 squared plus 2 squared. Plus, now I'm not going to factor out an 8 here. I'm going to factor out just the 4, and you'll see why in just a minute. So 4 times the inverse Laplace transform of 2 over s minus 1 squared plus 2 squared. Minus the inverse Laplace transform of 1 over s plus 1. All right, now we can see that this looks very much like this down here with an a of 1 and a b of 2. So this is going to be 3 times e to the 1t times the cosine of 2t plus 4 times, this is why I left that 2 in here, because now this 2 and that 2 match up. That's our b, and our a is 1. This is in our sine function. So this is going to be e to the 1t times the sine of 2t. And over here, this is just our e to the at with an a of -1. So minus e to the -t. And there is our inverse Laplace transform for this function of s.